Okay, welcome back. So, you see here we have the sample electron filling. If you are in 6th or 7th period, you have a copy of this on your periodic table. If you are in 8th period, you just need to know this. That's why you're in honors. Okay, but this is called basically an Aufbau diagram. What this shows us is that as we move up, our energy, see if I can write this neat. Energy increases as you move up. So the 1 would represent like the first level, and S is the sub-level. Now the first level only has 1 S in it. But now we get up to the second level. See how we have a 2 here and a 2 there? So we have, that's all in the second level, but it's divided into an S sublevel and a P sublevel. Same with the third energy level. It's divided into an S sublevel and a P sublevel. Now each box here represents an orbit. So the S has one spot where the electrons can go. So this box can hold 2 electrons. This 2s can hold 2 electrons. Now with the P though, because P has the 6 different lobes, this would be one pair of lobes, this is another pair of lobes, and this is another pair of lobes. So the p orbital can hold up to 6 electrons. So let's start with an electron, and we'll just, so quick, what's your favorite one? Oh, I heard somebody shout out magnesium. Okay, so you look at magnesium. So do this. Okay, first off, how many electrons does magnesium have? Well, you look at the atomic number on your periodic table, which is the bottom one. It has 12 electrons. So we go up, we go, one arrow represents an electron. Now, for things that we don't need to cover, but we're going to do it correct, we put one pointing up and one pointing down. That means it has an upspin and a downspin. Next year when you take AP, you'll learn about that. So 1 electron, 2 electron, 3 electron, 4 electron, 5 electron, 6 electrons, 7 electrons, 8 electrons, 9 electrons, 10 electrons, 11 electrons, 12, and we're done. Now notice how I filled these in. I went there, there, and there. First, because electrons do not like to pair up unless they have to. It's like when you're sitting on the bus, on the city bus. You don't just go sit by a stranger. You take your own seat until you absolutely have to give it up to somebody else. Okay, but you don't just randomly sit by strangers. So we have our 12 electrons and they pair up after they're half filled. So now we would write this. To write our electron configuration, we would go 1s2, 2s2. So I have my 1s has 2 electrons, my 2s has 2 electrons. Okay, my 2p, how many electrons are my p? Pause for a moment. Hopefully you have now written that it has 6 electrons. Okay, and then I have 3s, and how many electrons are in there? You should write that it has 2 electrons. So we would say that the electron arrangement for magnesium is 1s2, 2s2, 2p6, 3s2. Okay, that's your electron configuration, or the arrangement of where the electrons are located. Now, okay, hopefully that wasn't too bad. Always start with the lowest energy level, fill it in one at a time, and work your way up. Let's do some annotating with a couple different things. I want to go red just because that will stand out. Okay, so this number right here, that tells me number of electrons. The letters are my sublevels, and the big numbers in the front, they tell me what level I am on. So I know that in the third energy level of the S sublevel, I have 2 electrons. Okay, now to write the electron dot configuration, we have to go, again, chemistry is all about the electrons. So you take and you put the symbol. Now, how many electrons are in my highest level or my highest energy level? Well, I look, okay, what's my biggest number? I have 3 there. I have 2 electrons, so I put 1 dot, 2 dots. That's my electron dot structure for magnesium. Okay, let's try another one. Let's go with oxygen. Everybody loves oxygen because we like to breathe. Whoa, that's a funky looking O. Let's try this one. Ah, that's a lot better. Okay, how many electrons are in oxygen? You look, shout it out. You have 8 electrons. Okay, let's fill it in from the bottom then. 1, 2, 3, 4, 5, 6, 7, 8. Now, again, write your configuration. Well, I go 1s, how many electrons are there? 2. 2s, how many electrons are there? 2. In 2p, how many electrons do I have? 1, 2, 3, 4. So I'd go 2p4. Okay, now, tricky here though. To write our electron dot structure, let's look. What is my highest energy level? A lot of you will probably say, well, it's 2p. I have 4 electrons, so I should put oxygen, put 4 dots around it. Okay, that's how many you have in the 2p level. But to do the dot structure, we are concerned about the electrons in the energy level. So we have to look at all the 2's, the highest energy level. So I have 1, 2, 3, 4, 5, 6 electrons there. So I've got to put 1, 2, 3, 4, 5, 6. There's my dot structure. Now, let's talk a little bit more. Let's fill these notes in here, and then we'll give you some time to work on some examples. Okay, let's go back to, let's stick with red if that's looking okay for you. Okay, electron dot structurals are simple ways of showing the outermost electron shell of an atom. The electron dot symbol for an element consists of the chemical symbol for the element plus a dot for each outer valence electron. Dots are placed in 4 regions around the atomic symbol: the top, the bottom, the left, and the right. Each of these regions can accommodate 2 electrons. Now, this bottom part right here, if you understand how the periodic table is organized, it's not necessary to memorize the order in which electrons fill. You can write the electron configuration of element based on its location the periodic table. We'll cover this more on Monday because that can be a little bit tricky, and I probably should see what your faces are doing as we look at this. For today, we just want to be able to write this. Can we write configurations and know what they mean? And can we write dot structures? So we're going to practice with that now. What I'd like each of you to do is turn the page of your lab book, and you have different ones to practice here. So I'd like you to try to do potassium. Then I'd like you to try to do helium. Then argon. Let's do a little sulfur. Okay. Another one I'd like you to do is chlorine. After that one, let's do neon. And we will finish with sodium. Okay, so we're going to take about 10 minutes, work on those, discuss with your partners, and then we will see what happens afterwards.